Here's a particularly tricky problem from the quadratic equation unit, because we have to do two things here. First of all, remember we can't really do our solution by factoring until we have this written as ax squared plus bx plus c equals 0. And this one's further away from that than most problems. So there's one issue going on here we have to deal with, which would be, I want to clear this fraction. So I'm going to multiply both sides of this by x. So I multiply by x on the left, multiply by x on the right. Remember, multiplying by x will be the same as multiplying by x over 1. And so, so this is going to cancel out on the right-hand side. And so the equation will become x times 30x minus 11 equals 30. Now, there's a caveat to doing that, because when I multiply both sides by a number, there really can't be anything that can go wrong. When I multiply both sides by x, I can actually lose solutions, because that's not a meaningful thing to do if x is 0. It's allowed if x is 0, but it sort of ruins your equation. Because if you multiply an equation on both sides by 0, the new equation will just say 0 equals 0, which is always true and not meaningful. So one thing that some people like to do is, if they've done a step where they've multiplied by something that could be 0, they like to make a note of that next to it, and just point out that that when you did that, you were assuming that x wasn't 0. So you were assuming that you did not multiply by 0 on both sides. So it's not a bad idea to do that. Another effective way that you can be on the lookout for that is just if you make sure you check your answer back into the original equation. That would be another way of ensuring that you didn't accidentally do something that introduced incorrect solutions. But but I'll stick to this method of saying that if I'm going to multiply by something that could be 0, I'll make a note of it when I do it, so that at the end of the problem, if I get something that's contradictory to that note, I will realize it. Okay, so this equation then, if I rewrite this in our standard form, this would be 30x squared minus 11x, and then I need to subtract 30 from both sides. So that's just a rewrite of this using the distributive property and subtracting from both sides. And so now I'm ready to go to solve this. So now this brings up another problem with this. This is why this was one of the more difficult problems, which is, in our usual factoring method, I need to find two numbers whose product is negative 900, good Lord, and whose sum is negative 11, right? So I'm I'm looking at the product of these two things, 30 times negative 30, that's my negative 900, and the sum has to be this. So if I identify those two numbers, that's essentially identifying the outer and inner terms of FOIL, and that will allow me to factor this. But this negative 900 is enormous. So when we've been doing our factor pairs with regular sized numbers, we always started with the aim of just saying that 1 and negative 900 is a pair. But look at the sum of that. The sum of this is negative 899. That is so far away from negative 11, it's not even funny. So when that happens, you know that the factor pairs where these two factors are very different in size, there's no way in hell they're going to add up to negative 11. So don't feel like you have to do 1 and negative 200, 900, and 2 and negative 450, and 3 and negative 300. You really can skip ahead, knowing that the ones in between have a gap that's even greater. So for example, I could just jump down and say like 10 and negative 90, right? That's an obvious factor pair. And look at that. That sums up to negative 80, which is closer to negative 11 than negative 899 was, but it's still not all that close. And so I can jump ahead again. I could say, well, what about 20 and negative 45? Right. So with some experience with the numbers, you'll find that you really don't have to check every single one, or at least you shouldn't check them in the order of the most extreme difference to the least extreme difference if you can see ahead of time that the difference has to be fairly small. So 20 and negative 45, those sum to negative 25, so that's getting even closer to negative 11, but still not there. So I got to keep going. I could divide, I think the next number that's divisible by 900, now it's not so obvious, but 25 and negative 36 would be the next ones I'm going to hit. And that actually does what it's supposed to do. Another little fact that helps to make the factor pairing go more quickly is think about how 900 breaks down into smaller numbers. So 900 is really 9 times 100, right? And 9 is really 3 squared, and 100 is really 2 squared times 5 squared. So if I think about how 900 breaks down as a product of primes, and this is only helpful if the number is very large like this, but when a number like 900 can be broken down, and we see that it's 3 squared times 2 squared times 5 squared, there is no point trying any factor of this that's not built out of these factors. So I would never even try dividing 7 into 900 or 14 or 21 or 13. Any number that you use that's not built out of 3s, 2s, and 5s is definitely not going to be a factor of 900. And so if I can see that, then that's how I knew, like in this gap here, that there was no point trying 21, there's no point trying 22, right? Because 22 can't be written as just in terms of products of 3, 2, and 5. 23 certainly is not going to work. 24 is not not really going to work. I mean, that one's maybe not so obvious, but you could try it. And so really the next one I could possibly try is 25 here if I keep in mind what I know about the structure of numbers. So most problems don't have products that big, so I wouldn't lose a lot of sleep over it. But do be willing to accelerate this process. You know, if you see that your factor pairs add up to something that's way, way, way far from what it's supposed to be, don't be afraid to jump ahead. Anyway, so 25 and negative 36 is our factor pair, and so this is going to factor then, and I'll leave it to you to verify this. I think this is a good case where I would use the little table that we talked about in class. But it's going to factor. There's going to be a 5x and a 6x, and then I'm going to have an outer term of 25. Right, see how my outer term is 25, that's this guy, and my inner term in FOIL is negative 36, that's that term. So don't forget that what you're doing here is identifying the coefficients of the outer and inner term. So outer term is 25x, inner term is minus 36x. That's what you're trying to do over on this side. And so, so of course that's not even the answer. We really want to find the values of x. So I'm going to say, well, either 5x minus 6 is 0 or 6x plus 5 is 0, which means that my solution set is 6/5. 6/5 is the solution to this equation, or, I'm sorry, this is a plus sign. Or negative 5/6. Negative 5/6 is the solution to this equation. So that's my solution set for this. Definitely the hardest problem in the problem set, but I think that all of the variations on it will also work using these same basic steps.